A common thing that we want to do in science is we want to know what is there, or we want to qualitatively analyze something to know if something is present or absent. So for example, we want to test a solution to see if certain metal ions are present. We would want to do this because those metal ions might be harmful or might cause the water to not be of use. And we have a number of ways that we can do this in chemistry. The first way is, and simplest, is we can just use the color of the solution, because many of our metal ions, when they're dissolved in water, will give that solution a particular color, especially transition metals. Okay, so for example, copper 2 ion and chromium 2 ions would cause the solution to be blue. We have a number of ions that would cause the solution to be green. Okay, iron 3 would cause it to be orange. We have a couple that cause it to be pink. And then dichromate would give it a yellow or orange color, and permanganate is purple. So for example, if I had a sample of water from a source and I saw that it was blue in color, it would lead me to believe that maybe that solution contains copper 2 ion or chromium 2 ion. And so after that, I would then refine my analysis even more to be able to distinguish between those two possible ions. A second way that we can test a solution to see what metal ions are in it is through what's called a flame test. And with a flame test, what we do is we take a small amount of the flame or a substance and we introduce it usually into the flame of a Bunsen burner. And what this will do is it will cause the Bunsen burner's flame to change colors, and that changing color allows us to identify the compound. And usually we put it on the end of a wire with a little loop, and we put a drop of the solution in the loop, and we introduce it in the flame. So here's an example. So the Bunsen burner's natural flame color is blue. And with the addition of our loop of wire with a little bit of our solution in it causes the flame to change from blue to red in color. And so therefore we know that particular metal ions are present in the solution. So for example, these different ions would cause the solution to change these colors. So the fact that it was red when we introduced the sample into the flame suggests that maybe it might have been lithium. But lithium is not the only one that causes the flame to turn red. Okay, as we can see, both strontium and calcium also cause a red-colored flame. Okay. And we can get a green flame with copper, 2 ions. Okay. And this idea that introducing different metal ions into a flame to get the flame to change different colors is the science behind fireworks. And all we would do is we would take different salts and we would use these salts introduced into the high temperature explosion of the fireworks. And that would cause those metal ions to ignite, and we would produce our different fireworks of color. Well, if we go back to our solution where it was blue, and we said that it could be either copper 2 or chromium 2, we would have to do further tests to distinguish and determine which one it is. And so one of the things that we can do is we can use our knowledge of precipitate formation to identify which ion in particular it is. And often we'll do a sequential qualitative analysis forming precipitates because we want to test for both possible ions that are there. So we test for one first and either show that it's not present or remove all of that ion as present, and then we would test for the second. And to do this, what we would do is we would add what's called a testing reagent to it. And this testing reagent would be something that causes only one of the possible ions to precipitate out. So for example, if we had a solution that potentially had both strontium ions and copper and iron 2 ions, okay, and we wanted to be able to distinguish, what we would first do is we'd have to add something to it that would cause it to precipitate out. We want to add an anion to it because we know that these metal ions, which are positively charged, will join with the anion to form a precipitate. And so I would want to get an anion that precipitates just with my iron 2, and so I might use hydroxide. okay? Because I know that my hydroxide ion will combine with my iron 2, but it will not combine with my strontium ion. Now, I can't just go to the shelf and get an ion that I want to test with, but I have to add a testing solution that contains the anion of interest. So I would want something that has a hydroxide ion and a cation that won't interfere. And usually what we do is we'll use a group 1 metal ion, okay, like an alkaline metal ion. So for example, I might use sodium ion. And so therefore, I would go to the shelf and I would look for or get a solution of sodium hydroxide. And the reason that I would want to get the sodium hydroxide is it would allow me to deliver my hydroxide ion to my solution so that it could potentially interact with any iron 2 ions that are there. But the group 1 metal wouldn't combine with anything that's in solution as well to form a precipitate. Okay, and so if I add my testing solution and I get a precipitate, what this would tell me is that my iron 2 ions are present. And it would precipitate out iron 2 hydroxide. If no precipitate forms, though, it doesn't tell me that strontium is there. All it tells me, and the only thing I can say is that there's no iron 2 ion in my solution. To determine or show that the strontium ion is there, I would have to add a secondary testing reagent. Okay? Now, if my iron 2 ion was there, I would have to ensure that all of it was removed from solution. Because I don't want any potential iron 2 ions that are present to interfere with my test for my strontium. And so what I can do to remove all the iron precipitate that might have formed if there was any present, I can remove it in one of two ways. The first way is that I could spin it at high speeds, and what this would do is this would cause all of the solid to sink to the bottom because it's more dense. Okay, and then it would form a pellet at the bottom, and my supernatant that's still at the top would contain my other ions that I could test for. My other thing that I could do is I could filter it where my filter would capture any solids, okay? And then the remaining solution that passes through, which we call our filtrate, could then be tested for other ions. Now that I've removed all the iron 2 ions, or I showed that they're not there, I can then go on to test for the presence of my strontium ions. And I can determine if strontium is present or not in the solution. And so what I can do is I'll go and get a second testing reagent that would cause a precipitate with it, and I might decide that I'm going to use sulfate ions. Now, I know sulfate ions would also cause a precipitate with any iron 2 that's present, but since I either showed that its iron 2 is absent or I removed it, then I don't have to worry about any potential interference. So I will go and get a testing solution that contains my sulfate ion and a cation. And again, I want a cation as part of my salt that will not interfere. So I'll choose a group 1. And this time maybe I'll pick potassium sulfate because again, potassium is a group 1 metal and we know that they're soluble with all compounds. Okay, and I know that if a precipitate forms, then my sulfate ions are present. Or sorry, I know that if a precipitate forms, then that my strontium ions are present. And I would form a strontium sulfate precipitate. And if there was no precipitate, the only thing I could say, since this was a test for strontium ions, is that strontium ions are not present. One of the things that we can do to organize our thoughts when we want to do our sequential qualitative analysis is we can use a flow chart. And so what this does is it allows me to follow the sequence of my tests and their possible outcomes. So for example, I have my solution with strontium and possibly iron 2, and I said that I was going to add some sodium hydroxide solution. And we have two possibilities. We can have a precipitate form or no precipitate. We've already said if no precipitate form, since this is a test for my iron 2 ions, I can say that there's no iron 2 ions present in the solution. And again, that's the only thing I can say. It tells me nothing about the possibility of strontium being there. This only tells me about the iron 2. And if a precipitate does form, then I can say that my iron 2 ions are present, and my precipitate that forms would be my iron 2 hydroxide. So now we will know that our solution might contain strontium ion, and we have to test it. So we'll add our second testing solution, which we said was potassium sulfate. And again, we have two possibilities. If no precipitate forms, then what that tells us is that my strontium ion is not present. But if a precipitate does form, then my strontium ion is present, and I form a precipitate strontium sulfate.